Okay, this note 6 over the standard normal curve. So first, before I introduce the standard normal curve, I'm going to talk about the empirical rule. So remember, in the empirical rule, we were using raw data. And all that means is we're able to easily find mu and sigma. So here mu is 7, sigma is the distance between each one. So I could say 8.2 minus 7, which is 1.2. And that tells us that if we were to label this, this would be mu, this would be plus sigma, plus 2 sigma, plus 3 sigma, and then minus sigma, minus 2 sigma, minus 3 sigma. Or we can standardize the curve and use what is called z-scores. Okay. So for z-scores, we know that the center right here is 0 because you are 0 standard deviations from the mean because you are on top of the mean. On either side, you would be 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. Or in other words, you would be z equals 1, c equals 2, and z equals 3. And then same on the other side, but negative. So -1, -2, -3. And then the same applies here. Okay. So we can do that one of two ways. We could use the standard normal probability table in order to find the area under the curve left of z. Okay, so notice in this diagram of the table, we have everything shaded to the left. That is telling us we are trying to find the percent of data that is below that z-score. Okay, here is the table. Okay, this is only one bit of a larger, more broad table. I'm going to show you how to do it on the table, how to find your area, and then I'm going to show you how to do it on Desmos. Okay, and then from here on out, I would prefer if you just use Desmos. Just to make it go smoother and faster. Okay, so let's first look at this one. It says what percent of data is below a z-score of 0.54. So here is my normal curve. Here is 0. I know 0.54 is in the positive direction, and I want everything below. So that would be everything to the left. So that this entire shaded region. So I'm going to go down to my table, and I'm first going to look at the left side, and I'm going to find 0.5. Then I'm going to go to the top, and I'm going to find 0.04. So together, that makes 0.54. Where they overlap or where they connect would be the answer. So in this case, the area that is below 0.54 would be 0.7054. So that's what I would write here. So this is equal to 0.7054. And I'm going to do the same thing for the other two examples. Okay, so example 2 says what percent of data is below a z-score of 1.08? Well, here's my normal distribution. Here is 0. I know 1.08 is going to be on the right side, and everything below it is going to be to the left. So this entire part here. Now, looking at my table, I'm going to find 1.0, and then I'm going to find 0.08 to make 1.08, and then wherever they intersect is going to be my area. So that means my answer is 0.8599, or approximately 86% of data is below the z-score 1.08. Okay. Notice we're able to get a more accurate description of that percentage versus using the empirical rule where we only had the percentages broken down so far. So we only had the 68%, the 95%, and the 99.7%. Okay. Now, this one is asking what percent of data is above a z-score of 0.17. So here's 0, here's 0.17, and I want everything above, which means I'm looking to the right. However, this table over here only knows the left side. It only knows this part. So I have to first find that. So in order to do that, we have to find the left side first. Okay, so we're finding the area of the left of 0.17. So here is 0.1, here is 0.07. Where they intersect would be the area to the left. So that means this area is 0.5675. Well, we know that the entire distribution equals 100%, or in this case, 1. So in order to find the right side, we could do 1 minus that value. So 1 minus 0.5675 gives us the area under the curve, which is 0.4325, or the one that we were trying to find. Okay. So in this next part, I'm going to show you how to do this on Desmos. So notice here, you have this part that says TI-84. Okay, we're crossing that out, and I had you guys put a sticky note over this and label it Desmos, and then normal CDF. Okay. I'm going to give you the steps on how to put this in Desmos, and then we're going to do the same 2 problems we just did above, but now using Desmos. So your first step is to go to Functions. Okay. When you're on Functions, you are going to find Normal Distribution, or DIST. And when you click on it, it's going to pop up as parentheses, and you're going to have to type 2 things in. And these parentheses is going to be mu and sigma. Since this is a normal distribution without any given mean or standard deviation, here you're just going to put 0, 1. So you do normal distribution, 0, 1. Once you do that, you're going to go down, and there's going to be something that says cumulative probability. Okay. And then under that, there's going to have a section that says regions. Okay. You're going to have an inner, an outer, a left, and a right region. If it's telling you to find the percent of data below the z-score, then you're going to use the left. So left is below. If it says find the percent of data that is above the z-score, then you are going to look at the right side. Yes.
You have a class, do you?
No.
Do you have Johnny Cortez in any of your classes?
No. It's probably the wrong room.
Yeah, sorry.
No, it's okay. And then for the region inner, it's going to say, is your z-score between these 2 values? So looking at these examples, the first one says what percent of data is below. So that means when we find the region, we're going to look at the left. So over here on Desmos, I'm going to go to Functions. I'm going to scroll down until I find Normal Distribution, so right here. So normal, DIST. And in here, I'm putting mu and sigma, or in this case, 0, 1. When I put those values and I click on this little magnifying glass that has a plus sign, it's going to re-put my graph so it's right in the center there. I'm then going to go where it says cumulative property, and I want below, so that's left. So when I click on left, this value here, I am just putting the z-score. So 0.54. And then notice it's going to give me my answer, and if I click on that little drop down, I can see more than just those 3 decimal points. So here I get that the probability is 0.7054, which is the same thing I got when I did this using the table. Okay. And then I'm going to do the same thing for 2. So in this case it says above, so I'm going to go to the right. So I don't have to re-click anything. I'm just going to go to right, and I'm going to re-put this number. So instead of 0.54, I'm going to put 0.17. Hit the drop down because I went about 4 decimal places, so I get 0.4325. That's my answer. Okay, on number 3, it wants me to know what percent of data lies between. So I'm going to go to enter because it talks about in between, and I'm going to type in each of my z-scores. So I have negative 1.64 and then positive 2.33. And if I hit the drop down right here, I get my answer is 0.9396 because I'm rounding that last decimal point. Okay. Let's also say that I need to draw the diagram. Well, if I look at Desmos, it's already drawn for me. So I'm going to do my normal curve. I'm going to make sure I label my 0, and I'm going to label my negative 1.64 and my 2.33. And since this is everything in between, I'm going to make sure that I only highlight everything in between this. Okay, so everything that I shaded is the area 0.9396 or approximately 94%. Okay. Now, let's talk about raw data to percentages. Okay. The example says, on a typical Saturday, Fiesta Market reports that the mean amount of money spent by customers is $27.21. So, mean. And the standard deviation is $7.93. The distribution is approximately normal. Okay. Number 1 says, what percent of people spent less than $20? Okay. Well, we are trying to find the probability that people spent less than $20. Okay. Well, that's the same as saying the probability of Z is less than, and then recall that our formula for Z-score is Z is equal to X minus mu over sigma. So I'm going to say Z is less than 20 minus 27.21 over 7.93. Well, if I simplify that, I get P, or the probability that our Z-score is less than negative 0.91. Well, I can do that by going over to Desmos. Notice that this is Z is less than, so I'm looking at the left side. And then here, I'm going to type in negative 0.91. Drop that down, and I get that the percentage of people would be 0.1814, or approximately 18%. So approximately 18% of people spend less than $20. Okay. Then I'm going to look at number 2. Number 2 says, what percent of people spent above $40? So I'm going to do the same thing. So that's the probability that X is greater than 40, which is the same thing as the probability that the Z-score is greater than 40 minus the mean, 27.1, over sigma, which is 7.93. And that is equal to the probability that Z is greater than 1.61. So greater than means I'm looking at the right side. And then I'm going to plug in 1.61. And then I'm going to get 0.0537, which tells me about 5% of people spend above $40. Okay. Number 3 says, how many people spend between $25 and $30? So that's the probability that they spend between $25 and $30. So that is the probability that Z is going to be between 25 minus 27.21 over 7.93. And between 30 minus 27.21 over 7.93. So I'm just using that formula for the Z-score. This gives me the probability of negative 0.28 being, Z being between negative 0.28 and 0.35. So I'm going to go to enter on Desmos, and I'm going to type in those two numbers. So negative 0.28 and 0.35. Negative 0. Oh, I typed this in wrong. 0.5. And then that gives me my answer of 0.2471, or approximately 25%. So approximately 25% of people spend between $25 and $30 when going to Fiesta Market. Okay. So this next part says, okay, let's say we're finding these percentages and we have to convert them into z-scores. Well, we kind of already did that up here, okay? When we had to find something that was lower, okay, ignoring this portion because this is talking about the TI calculator. If we had to find something that was lower, then we had to look at less than, or the left side, versus if something was above, greater, or higher, we had to look at the right side. That's all this portion is saying here. That all of these words mean less than, lower, less than, below, and all of these words mean greater than, greater, more than, above. Indicates if we're going to look at the left or of the right side. Okay. Same with between. Okay. For between, we're going to look at both of them, and notice how when we did our problem, we had to do the formula for z-score twice. So we have the probability of the low z-score and then the high z-score where the z is in between. When we're looking at this on Desmos, we use the region inner. Okay. Okay. Next part, percentages to raw data. So we just did raw data to percentages. Now we're doing vice versa, percentages to raw data. It says, this time, let's suppose we had to work backwards. Our example says, on a typical school night, students get an average of 7 hours of sleep with a standard deviation of 1.2 hours. So average means mean, so average is 7, standard deviation is 1.2. How many hours of sleep would a student need to be in the 75th percentile? Well, 75th percentile is the same as saying 75% below. So in this case, it says, is this going to be positive or a negative z-score? So if we look at the 75th percentile, okay, we know that that is going to be somewhere over here. Okay, this is the 75th percentile. Anything below that would be going to the left, right? However, that doesn't mean our z-score is going to be negative, because if the 75th is right here, that means our mu, or our 0, is somewhere here. So this tells us that our z-score is going to be on the positive side because 75th percentile is closer to the 100th percentile on this side versus the 0th on the other side. Okay, so now let's say we need to use the function called inverse norm to find this on Desmos. So again, I had you guys not look at this, okay, and put another little sticky note there because I'm going to show you how to put this in Desmos. Okay, so pretending that's not there, I'm going to zoom in over here. You're going to label your sticky note Desmos, and this is called inverse norm. Okay. So in order to do that, you're still going to have your normal distribution. Okay, your first step is still that normal distribution of 0 and 1, signifying mu and sigma. And then what you're going to do next is you're going to put a dot right after the norm distribution. Okay, and you're going to put inverse CDF. So you're going to put dot inverse CDF. And then in the parentheses, you are going to put the percentage that they give you, or the percentile. So this is the percentage. Okay. When you do that, this is going to give you your Z value. So it gives you your Z-score. If you need to find X, you have to plug that into the Z-score formula. Z is equal to X minus mu over sigma. Okay. So now let's show this on Desmos. Okay. So step 1 is to find your Z-score, okay? Step 2 is to find the raw data, and that's what I meant by to find X, plug it back into your Z-score formula. So example says if Z is negative 2.3, mu is 23, and sigma is 5, what is X? Well, remember, if in order to find X, you have to plug back into your Z-score formula. So Z is equal to X minus mu over sigma, which means I have negative 2.3 is equal to X minus 23 over 5. And if I get X by itself, I get X is equal to 11.5. Okay. In the next couple examples, it's now asking us to find our Z-score. So it says if you have 20% of your data lying below a Z-score, what is your Z-score? Well, in order to find this, I would have to find the inverse norm of 0.2 because 20% as a decimal is 0.2. So I would go over here, and on my normal distribution of 0, 1, I'm going to do dot, and I'm going to do inverse. It might not let me just type it all in. Let me see if I do dot and then go to functions. Right here, inverse CDF. And then from inverse CDF, I'm going to type in 0.2. Okay. And that gives me my answer. So this is saying Z is equal to negative 0.8416. Okay. Now that I have it set up, I can just change my number. The only thing I have to know is that I have to turn my percentage into a decimal. Okay. So this says in number 3, again, if you have 20% of your data lying below a Z-score, what is the Z-score? Okay. This one says if you have 34.5% of your data lying above a Z-score, what is your Z-score? So here, I can't simply type in that 34.5 because that is only going to give me one side. And I'll show you that here. So if I was to delete this and turn 34.5% into a decimal, that would be 0.345. 0.345. Never mind. Desmos is that awesome. Okay. So, scratch what I just said. Once you turn the percent into a decimal and you plug it into the function, once you plug that in, we get our Z-score. Let me check something real quick, because now I'm curious. So let's assume that we were looking at the data table like we were doing in the beginning, and we had to do 1 minus 0.345. to give us 0.655 if I was to type that in. Okay, so notice our answers were pretty similar, but one had a negative z-score and one had a positive z-score. So it looks like you could type in either way. You would just have to know that lying above a z-score means we're going to have a positive z-score, because our chart would look something like this. Okay, here is 0, here is z. We know that 35% of the data is above, which tells us that our z-score is going to be positive. Okay, so when we do this and we end up doing the 1 minus the percentage to make sure we're on the positive side, we do get z is equal to 0.3989. But when we did it before, so going back to how I had it before, 3, 4, 5, notice that I got almost the same thing, but it's negative. So you could do that. You just have to remember that if we're looking on the right side versus the left side, if our z-score is going to be positive or negative. Number 5 says if you have 35% of your data lying symmetrically in the middle of your distribution, what are your z-scores? Okay, so what does that look like before we start trying to find this? So this is our distribution. Here is 0, here is our negative z-score and our positive z-score. If we look at everything in the middle, that's going to be just the z-scores in between those two values, because they're saying that this right here is 35%. Okay. If this is symmetrically in the middle, that means we can technically know the values on either side, because the entire thing is 100%. So we do 100 minus 35, okay? That would give us 65. 65 divided by 2 gives us 32.5, which means either side is going to be 32.5%. And what we need to do is we need to find the inverse norm of this value, 32.5, and we know one of our answers is positive and one of our answers are negative. So if we turn that into a decimal, 32.5 means percent is going to be 0.325. If I plug that in, 0.325, I know I'm going to get a z-score of negative 0.4538 and also a z-score of positive 0.4538 as my answers. Because I know I'm going to be in between, I have to have two different z-scores, one on the positive side, one on the negative side. Okay. Now what if I have a question like this? What z-score corresponds to the 45th percentile? Well, all I have to do is just find the inverse norm of 0.45. So I'm going to go ahead and erase this, put 0.45, and I get that this is equal to, z is equal to negative 0.1257. Okay. Next portion of the notes, let's say we have percentages and we need to convert them to raw data. So now we're combining the two things. We're combining using inverse norm, and then we're combining using our z-score formula to find x. So number 7 says, on the most recent test, a student scored in the 40th percentile. The mean of the test scores was 85 and the standard deviation was 1.5. What was the student's score? Well, if the student score was in the 40th percentile, then we need to do the inverse norm of 0.4. So that's what I'm going to do first. Okay. Getting that, I'm going to get negative 0.2533. Okay. This, remember, is our z-score. Okay, so then I use my formula. Z is equal to x minus mu over sigma, implies that negative 0.2533 is equal to x minus 85 over 1.5. Solving for x, I find that x is approximately 84.625, which means that they scored approximately an 85 on the exam. Okay. Number 8 says the automobile dealer finds that the average price of a previous owned vehicle is $8,256. He decides to sell cars that will appeal to the middle 60% of the market in terms of price. Find the maximum and minimum prices of the cars the dealer will sell. The standard deviation is 1150 and the variable is normally distributed. So, let's draw this visually to see what we're trying to find. So here's 0, here's negative z, here's positive z. They want us to find something that appeals to the middle 60%. So this is 60%, which means these two outside values are 20% in order for it to add up to 100%. So we need to find the inverse norm of just one side of this. So inverse norm of 20% or 0.2. Okay, tells us that we can get a z-score of negative 0.84 or positive 0.84. So knowing that, we're going to have to check both sides, and this is going to help us find the maximum or the minimum. Okay, so doing that, I'm going to have negative 0.84 equal to x minus 8,256 over 1150. And then 0.84 equal to x minus 8,256 over 1150. Solving for x in the first one, I get x is about 7,290, and then solving for x in the next one, I get 9,222. My minimum and my maximum value. So this means that the dealer should price the cars between 7,290 and $9,222. That would be our answer.